All right, something a little bit different today. What in the heck is this crazy pile of aluminum? Well, some people struggle when they do 80%. They go ahead and they pick up an 80% and they go ahead and they mill it out and it's all great. And then they decide, hey, let's get this engraved. And then they have a hard time finding an engraver that wants to take custody of what is now technically a firearm. Now, this one, it hasn't been milled yet. This is still an 80% paperweight. You could drop this off at any trophy shop, in any place that does engraving, no problem. But once it's been milled, well, then technically to leave it overnight with anybody, they have to have an FFL. Well, if you can build a receiver at home, why not do the engraving yourself? So that is what this crazy pile of parts is all about. Now, before I dive in and put these back together and show you what it's all about, let's get a tape measure over here, and we'll take a look at some measurements that are kind of critical here. Now, probably the simplest piece are the two back struts. Pretty straightforward. It's just 1-inch square aluminum tubing, and if I measure, the key measurement is between those two holes. It's exactly, it might help if I get in the frame here, exactly 17 inches between those two holes. Now if we move over here to the front, now this is a little odd because my Dremel is actually running through these two struts, but other than that hole for the Dremel to pass through, these two front struts are exactly the same. And if I put the tape on here, well, you might have to take my word for it. It's exactly 17 inches between the holes, because it's the hole-to-hole spacing that is the critical measurement. So we have two back struts, holes are 17 inches on center, two front struts, holes are 17 inches on center. Then, to complete the parallelogram, I have a left side, which is just two pieces of 1-inch square aluminum tubing, but this time the holes are 4¼ inches on center. That's the easy piece. Now the only piece, a little more complex. This is the piece that will act as the fourth side of the parallelogram. These two holes, 4¼ inches on center. So that's the final fourth side of the parallelogram. But then it's going to continue. So these two pieces of square tube are 10¾ inches. And they then bolt to a top piece that's 10½ inches and a bottom piece that is just a hair over 12½ inches. Now, some of these dimensions aren't super critical. The final dimension that is critical is the dimension from this hole to the stylus. And right now, from that hole to the stylus, if I can get this right on, we're looking at 12¾ inches. Because this is going to be the key piece. Now, once I bolt this parallelogram together, I need a carriage, and the carriage dimensions aren't critical at all. But this is my carriage. You'll see how it fits on in a minute, and I'll show you why it's on a pivot. All right, so let's start putting this thing together, which, trust me, sounds easy, but it's a pain in the tuchus. And that's what these big pins are for that I made. Now, everything else is aluminum, but the pins are steel, just so that the pivot point would be a little bit harder. And then I have these little Teflon washers that I put in between all the pieces. All right, now I'm going to shut the camera off for a minute, and we'll be right back. All right, just about ready to go. This is how the milled lower is secured. We're actually using 1/2 of the jig. The jig is then actually screwed to the table, to the workbench. Then the 2 alignment pins that align the 2 halves of the jig with the lower are inserted. That aligns the lower with the jig and keeps it from moving in the X or Y direction. And then I just used a little bit of hardwood with 2 screws to press it firmly against the jig, so now it can't move in the Z direction. So that lower is now absolutely fixed in place. Then I'll take the engraving bit and roughly position my pantograph until it's over the selector hole. Right there, it's like on the top edge, dead center. Well, then I come over to my table and then I tape my template so that it's right in the exact same spot, top of the selector hole, dead center. So that way my printed template matches the position on the lower. So now anything I trace should be milled or engraved into the lower in the exact same spot. Now, of course, when I printed this on the computer, this is now 4 times full size, so that when it goes through the pantograph and gets reduced by 4, it'll be perfect size on the lower. All right, so let's go ahead and step back. Let's fire this thing up, and let's see if this crazy contraption works. All right, let's go ahead and clean it up and see what we've got. I mean, right now it just looks like a big mess of shavings. So let's give it a blast. Well, it's not going to win any awards, but it's better than a freehand. I'll probably adjust my depth setting, go just a shave deeper, and then trace it a second time to clean it up a little bit. But with a little bit of color fill after anodizing, I think that's going to work. So there we go. A homebrew pantograph using a Dremel to do engraving on lowers.